Hello and welcome back to the MM-Tek topology. We're now on episode 4. I went through between the last episode and now, and I went ahead and did the configuration on all of the routers here in the core. Today we want to verify that we have all of these connected. That's step number 1. And then step number 2 is to start configuring our ASAs that we have. I'm going to open up Switzerland Edge. So one of the things you might have noticed here is that we have sort of a pattern in the way these are done. So we have 10.1.0.0, 10.2.0.0, 10.3, 4, 5, 6, 7, 8, 9, 10, 11. And that's convenient because when we go into Switzerland Edge here, and we'll enable here. And we're going to do show IP route. And when we look at this particular router, and this router is connected to everything, and should be connected to everything, and even if it wasn't, we'd still be able to see this. But if you look here, we've got 10.1, so we've got, the connected and local that show up here for 10.1 because it's directly connected. If you look at these others, we should see everything 1, 2, 3. Now, for some reason, 4, 5, and 6 are not showing up. And then 12. So, I'm not sure if this is because this is not fully. Oh, it is. So now that I should have waited just a moment for the topology to have converged. So now if you look here, we see 1, 2, 3, 4, 5. Still not seeing 6. It's 7, 8, 9, 10, 11, 12, 13. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is not up just yet. So what we need to do is we need to go back here to the America Edge. Let's show up around here on this one. Let's see. Okay, so we can see 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so that looks okay from there, and I think our convergence time is a little bit slow on this. Let's try again. Oh, it's up now. Okay, so this is what we're really going for. We want to be able to do a show IP route. We want to see local and connected. And we also want to see OSPF, since we're running OSPF for the core of our router topology. So we can now determine that we should be able to reach any particular router itself. Now, one of the other things that you really need to do is to ping from Switzerland Edge here out to this particular connection, and then to this particular connection, and to this one, and then out to here, 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 and here, and so forth, because this topology, like this link could be down here, and it's going to go out this way and up here if this one is down, or if those two were down, it might go down here and back up here. And so you do need to ping the individual interfaces on each of the routers from Switzerland Edge just to verify the connectivity of everything. So that's the first piece, and then we want to actually go in and start the configuration on the ASA. So I'm going to console in Germany here, and I did go through and put the host name in. It's in lowercase, so we're going to be changing that in just a moment. And what's going to happen when you first start up your ASAs is that they are going to start up. They're probably going to shut down and start up again. If there's an issue with that shut down and restart on the first time it goes into a loop, then you actually do need to do some troubleshooting. But that just because it shuts down on the first time that you start it up doesn't mean that there is an error with it. Now, there's going to be a lot of commands that are going to be similar between the ASA and the routers or the switches. But there's going to be some things that are going to be different, and you're going to have to kind of, so I'd say at least 75 to 80% of the commands are different. 20 to 25% are not going to be the same. They're going to be similar, and you just want to go in and give it a shot, and if it doesn't, then that's where you use your question mark. Now, when we do enable here, it's going to actually show up with a password. If it has not been configured, then that password is blank. So it always shows up and acts like it has a password on it, whether it has one on it or not. And so we'll go back and we'll do our CONFT. We'll set our host name first. So we want this one to be Germany-ASA. And the next thing is we want to do enable password admin. Now, on a real ASA, you want to enable secret admin. But let's try this right here. And we're getting an invalid input detected. And that's not because that's not the right command. It's just that this ASAB has a bunch of stuff disabled just so that you don't use it out in real life. So that's one of the quirks that happens with using the V image, because you wouldn't really put a ASA out in the world that didn't have, and here you're getting that little warning that it's unlicensed and that you need to put license on it for full functionality. And that is one of the really big functional pieces that doesn't work there. Okay, so the next thing that we're going to do is we're going to be configuring our interfaces, and normally what we do here is we do show run. Now, normally if you were in global configuration mode on a router and you did show run, it wouldn't let you do that. You'd have to use the do command, so do show run. But the ASA will let you do that. There's going to be a lot of configuration in here, and you're going to ignore most of the stuff that's sort of built into the router. The functionality to allow it to have a ping come from inside, go out, and then come back. That's stuff that we're not going to necessarily deal with. Some of that higher layers of the OSI model and functionality there. All we're getting in here to do right now is we're looking at our interfaces, and we notice that they're gigabit, and they start with 0/0 and 0/1, 2, 3, 4, etc. Again, translation, all this stuff we're going to ignore in our crypto certificate. We will talk about class maps and policy maps just a little bit later. So that's our configuration. We just got in and did a show run just to do our interface configuration. Now we need to do int g0/0, I think. And what I'm going to have to do here is first off look over here. So 0/0 is our connection out to the Germany edge. If I come over here, the IP address here should be 10.14.0.1. 14.0.1. That would help if I actually put the word IP address at the beginning. And then the next thing that we need to do is we need to name the interface. So name interface, and we call this one outside. And we do that because it has an automatically, so if you notice here when I hit enter, it says security level for outside set to 0 by default. 0 is the most secure, and then we have 100 is the least secure. And then there's a we used to refer to it as a waterfall, and water will go from a higher number to a lower number without being checked, but it won't go the opposite way. So anything that's coming in from outside has to be checked. Anything that's going from inside to outside doesn't have to be checked. Anything that's going from inside to DMZ doesn't have to be checked, but to go from the DMZ to inside does have to be checked. So hopefully that's not too confusing. So we have our outside interface set up. Next thing that we want to do is determine which interfaces are inside interface. And to do that, we're going to have to kind of switch back over here. And we have 0, 1 set up as our inside interface. And our inside, so for the topology here, all of the inside are set up as 192.168.0. And that's because they're going to be, they're behind the firewall, so they're netted. So it doesn't really matter what IP addresses are there. So we would normally use private IP address. Okay, so we got G0/1, and then our IP address is going to be, let's go ahead and do our name if inside, and you'll see that the security level is automatically set to 100 by default. The next thing we're going to do is put our IP address, and our IP address for this is 192.168.0.1. And we'll do no shot on that one. And we're going to do G0/2. Name if DMZ. Now you'll notice that the security level is set to 0 by default, but we actually do want people to be able to get in there, and we're going to actually be putting rules about that. But we're going to set the security level here to 50. No shut this one. And so that's our interface configuration for those particular interfaces on this Germany Edge router. We are going to set up network objects. Those are going to allow the translation of our inside private addresses to outside interfaces. So what we're going to do is our 192.168 network. Those devices are not going to be visible from outside. If they are making a connection to outside, they're going to use that 10.14.0.1 with a specified port number using port address translation. So that's what we're going to do with that. And then our DMZ, that 172.16.1, is going to be translated into 10.14.0.3, and we're going to show that. Our interface configurations are done, so now let's put our network objects. So we'll do object network, and we're going to call this one just inside net. That's just something that we're putting. So object network is the command, and then inside net is the name of our inside network. And we're going to do subnet 192.168.0.1. 192.168.0.0. So that means we're going to port translate anything that's in this 192.168.0 to an outside address. And then we'll do the nat command in nat space inside, comma, outside. So we're natting from inside to outside with a dynamic interface. And then we want to do object network DMZ net, just to keep this consistent here. And we're only going to have this one host, which is 172.16.1.2. We're going to take this host address and we are going to nat our DMZ to outside. And we're going to statically assign this. So we'll do static, and then the address needs to be something that is in this 10.14.0 network. Obviously, .1 is used by the ASA and .2 is used by Germany Edge. So we 10.14.0.3 sounds like a good address for us to use for that. Okay, so that gets the network address translation, port address translation set up. We also need to do routing. Now, what we're going to actually do here is we're just going to set this sort of up as the default gateway for the devices that are inside of our Germany LAN. We're going to just do a static route, quad 0, for those of you who've done lots of routing before. So we're going to do route outside So basically we're going to say that anything with any mask that is inside here will be sent outside if it doesn't know where it's going. And we're going to use the next hop address of Germany Edge, and that address is 10.14.0.2. Sorry, off the edge here. And it always helps to spell correctly, so route outside. That will take everything that's inside of the ASA, and if it doesn't know where to send it, it automatically will send it out to Germany Edge. So anything that's not in the 192.168.0 network, it's automatically going to send out. Because when you think about this, it knows about the 192.168 network. It knows about the 172.16.1 network. Those are ones it knows about because it's directly connected to them. Anything that's not directly connected to needs to go out to the internet. I'm going to put an access list on at this particular point. I'm doing this because I want to be able to determine that my configuration is working, and nothing works on an ASA without an access list. But this access list is going to be really, really bad. So we're going to do access list out to in. This is an extended access list. And we're going to do permit IP any. So those of you who've done access list, again, I'm not keyboard here. I'm going to blame it on the keyboard. It's making me miss type here. So This is an access list you'd never use in real life. This is permitting anything from anywhere, which is not something that we want to do. But I created this one access list that says basically allow anything, anywhere, just so that we can ping and hit the items that we need to hit and know that our basic configuration is working. Later on, we're going to come back in and we're going to look at access list in more detail, and we're going to actually create access lists that stop things instead of that allow everything. Now, every time we do an access list, we have to do an access group. And our access list was called out in. And we're going to do this inbound on interface outside. Okay, so this interface here is the outside interface, and this means that we're going to set this access list up for inbound traffic on the outside interface. It's a little confusing the way it has to be done there. So let's go somewhere like the America Edge, and so we can get to 10.14.02 and then 1, and then ready for this one. So 14.1 is this one here, 14.2 is this one. So we know router that wasn't that big a deal getting to there. This 10.14.1 is actually the ASA. And this, oh, I don't know that I even have set up. Yeah, I haven't set up this device here, I don't think. So let's go in to console here. And obviously it doesn't like our host name because it's too long. So we'll probably need to change the way we do those. So let's do, this is a virtual PC. We haven't set one up yet in this topology. But somewhere here there is an IP. So we do IP question mark, and let's do IP. Now, you know, this from outside, this appears to be 10.14.0.3, but inside we're setting this up as 172.16.1.2. We're going to do a /24. I'm looking up here at this. So this is the IP. This is the so this is the command IP. This is the IP address. This is the mask. So /24, and then it needs to have 172.16.1.1 as its net mask. Okay, so what I'm going to do now is I'm going to ping 172.16.1.1 to see if we can get to the ASA. And it doesn't. So, yeah, I don't know why I wouldn't be able to get to that. So I'm going to do a write MEM. That's the same thing as copy run start. The ASAs still use the write MEM. The routers do too. It's been deprecated for use on the routers, but it's still sort of recommended on the ASA. Well, so if you look up here, I've named the DMZ interface. I didn't actually put an IP address on it, so that's a problem. So let's go to int g0/2. I want to copy that. Let's save this. Now let's go back to Terminal Web. Let's try it, and it works. Okay. So let's go back over here and now try to ping 10.14.0.3, and now it works. Okay. So obviously you have to have an IP address on the interface for it to work. But so what's happening here now is that this particular router, or this particular web server, is set with an IP address of 172.16.1.2. But to all the devices out here, it appears to be 10.14.0.3. So that is a real network address translation. This one particular device is being translated out to the world, and it's the only one that's accessible inside of this network. Now, those devices that are on the inside here that are the 192.168, we're not going to be able to test those. Now, we can go from inside and ping out and get the information back, but we're not going to be able to reach them from outside, and that's the items that are port address translated. Okay, so this is sort of a basic setup for the ASA, and that's what we're going to do for now. So we're going to go through and we're going to set up all of our ASAs, and then that will be, when we come back, we'll go ahead and do some other VLANs and inter VLAN routing next, and actually set up all of our hosts so that they can connect. Okay, so that's going to be it for this episode. I do have one more thing. On the virtual PC here, I didn't do save. Now, I do want to point out, the virtual PC, sometimes you can save it and it doesn't save. It's really easy to go ahead and put it back on, so don't really worry about it, but I just did want you to, I didn't want you to go through and set up all of your PCs and then disconnect, and then when you come back in, nothing is saved. So, okay, now the episode is really over.